Draft science video. Alright, so I'm going to do a response video to a 5-minute video by Bill Nye. Has some little girl asking a question. I don't know, sometimes this stuff always gives you the creeps. You know, when they have little kids pretend to be intelligent. Yeah. Anyway, just play along.
You fall into a black hole, where do you go? You know, black holes, there's a black hole's face. And a wormhole is...
A wormhole is a crock of shit made up by silly people. Anyway, I mean, it's just annoying, right? It's, you know, it's gone. This is how the brainwashing, the brain, it's not brainwashing, right? That's too good a word. The smearing of the dew inside of the brain. Yeah, dew in the morning. Poo in the morning. Morning poo.
different because it goes to a new world. But
yeah, it's a new world, new universe, full of stuff. Yeah, made up stuff. Leprechaun and such.
those don't exist and black holes do.
Bo, I think that's your name. We couldn't quite make it out. But Bo, greeting.
Okay, I like Bill Nye. Yeah, I like him even more now. He's looking so kind of, you know, he's getting a little rustic. You know, it's good look. I like it. He's just kind of, he's like friendly, creepy. It's just, yeah, I like that. I mean, I'm heading there. I mean, I sort of have well, I'm not friendly though. So I'm unfriendly, creepy. But anyway, I like the creepy part.
Bill here. You're asking about black holes. That's a great question.
I'm going to ask you some questions, I think. There's a link that's going to pop on here where I can ask questions. So I'm going to do that.
The way I like to describe a black hole, it's a star. A black hole is a star. Now, when you and I think of stars, we think about the sun, which is giving off all this light.
Right. So this is so far so good, right? I like that. It's nice and simple. It's just saying, hey, it's a big thing. Right? It looks small, but it's big. It's full of stuff. Lots of stuff in it. Yeah, I like that. It's just what happens when a star eats too much. Yeah, that kind of thing. I like that. Okay, we're heading the right way. Submit a question. Here we go. Yay. Anyway, I'll try that later. Come on. Hit the button. I don't know why my mouse is like triple clicking or something. Ah.
But the other thing about the sun to keep in mind is it has a lot of gravity. Because it's huge.
Okay, see, it has a lot of gravity. So that's where it all gets a little funky, right? Because that's how we all think, like it has the gravity, and it doesn't really have gravity. It blocks gravity, which is kind of funny. It's like the opposite of having it. It's destroying it, in a sense. It's imbalancing the universe. But I did think about, you know, this was food for thought. That's why I'm playing this video, is because this is something I was thinking about before, and I wanted to get to this kind of thing. Because there's an implication, right? So here my theory has this implication, and the implication is the gravity isn't some internal force the Earth has or the Sun has. It's this external force. And the truth is that inside the middle of the Sun, for example, is like the exact inverse of gravity. It's that it's got a proportionately less gravity. And so the atoms inside the center of the sun were going to have a real headache because they're missing a lot of gravity. Nothing can get to them. Stuff can't get to them as easily. And so the theoretical black hole, where the density is so thick that you block all gravity, you know, all this external pressure, which would be the inverse, let's say, of the speed of light in terms of the amount of pressure, then there'd be nothing to hold the atoms together, and they would explode in the sense that all of their energy would just get released because there's no way for them to maintain any energy because they can't. There's nothing holding them together because there's no gravity. See, that's the implication here. So this you know, might be to my advantage in explaining or proving this theory, in the sense that I would speculate, I would argue that based on my theory, the strongest gravity is right on the circumference of a body like the Earth. We're in the strongest gravity, and if I start digging a hole into the Earth, the gravity will get weaker, not stronger, because I will be I will be eliminating mass underneath me that's now shielding me from gravity. And so as I get rid of that mass and I create less mass between me and the other side of the Earth, I will neutralize the gravitational imbalance. And if I could get to the center of the Earth, I'll neutralize all the gravitational imbalance. There'll still be gravity, because still most of the stuff is going to get through. Most of the gravitons will still get through, so my matter will stay together, probably. But you can understand why the center of the Earth might be generating some heat, is because the atoms can't, the heavier atoms, of course, won't have enough gravity to hold them together. So the simpler atoms are the only ones that can survive in, say, the Earth's core. That would be my theory. And suns, the problem is that the gravity blocks enough with a sun where it catches fire, because the matter in the center of the sun can't be matter anymore. The atoms just break down. It's just not enough gravity to maintain their orbits. The electrons shoot off, and the electrons fall apart, and the protons and the neutrons and all that stuff starts to degrade because there's not enough gravity to hold them together. Okay, I think that was okay.
And everything that has mass, everything that would weigh something here on Earth, has gravity. And the exact origin of gravity, where it actually comes from, is not fully understood, Bill.
Yes, it is. Yeah, I fully understand it. Well, not fully, but like mostly. So yeah, I got a huge advantage over everybody else. I don't feel too advantaged at the moment because no one's paying any fucking attention. But yeah, I'm first. I got there first. Should get something for that, right? Being first to cross the line of some kind, I should get something for that, right? Something.
If you could figure that out, you might change the world. But with that said,
yeah, but you know what? You can't change the world until somebody like you, like mentors or prodigies, or you have to like fund it, or you have to do something. You have to point to it, or you have to say, I saw this guy, and he's got this theory. Yeah, something like that has to happen, because it just ain't going to happen no other way. The dopey institutional authorities have to sit there. Some celebrity scientist somewhere has to take notice, or nothing will change.
black hole is a star so big. How big is it? It's so big that even light cannot escape it because it has so much gravity.
Okay, now this is where it all goes wrong. So, I like Bill Nye, but no. I mean, just people, I don't know why they think this idea that you could, first, that gravity could affect light, which is, by my theory, of course, it doesn't make any sense, because light is gravity. It's just gravity with a frequency. It's gravitons, two gravitons separated by a distance. And it wouldn't make any sense that the gravitons are gravitoning the gravitons. I mean, they're affecting each other, but you can't really affect the light thing in this kinetically perfect universe like I was describing, because even if the same photon doesn't go from here to here, the frequency will, the wavelength will travel in a straight line. It'll go right through the gravity. But it's just this whole concept of, you have this Einstein equation, E equals mc squared, and it's like nobody takes that seriously. Nobody really recognizes that the energy is in the matter, the speed of light, the function is inside the material structure, and just by logic you could say, well, it's not possible for something to be moving two directions at the speed of light. I mean, obviously something can't be moving in a direction and then also emit light in the opposite direction. I mean, it can't. How to say that? It could emit it, but I'm saying it can't do both at the same time. It can't. There's no logic to this understanding that you have to account for the movement of the things inside the atom. The atom has movement in it, and if you're saying that something's moving the speed of light, then that movement would add to the speed of light. And then you'd have to argue that something's moving faster than the speed of light. So it can't do this. Matter can't move anywhere close to the speed of light because it has these moving parts. An electron can't go, it can't be orbiting this way and then the atom move that way, the speed of light, because then this electron would be moving faster than the speed of light in part of its orbit, if you get what I'm saying. So it can't happen that way. And what I'm arguing happens in black holes is exactly what I'm saying, is the matter falls apart. The event horizon is the strongest gravity, and when it flies over that, its acceleration is insane. And that acceleration is in one direction, in. And that's where all the light's going. So all the photons it's creating aren't going out that way. They're going in that way, because that's where all of the pressure is one direction. So you're not seeing any light, because the material is being, every bit of its orbit is being oriented in one direction, and so the photons just aren't leaving in the opposite direction. The radiation. I have to look up this Hawking's radiation and figure out what the hell that is. Because why does that escape? I mean, the radiation still has to be moving at the speed of light. How can it escape? It doesn't make any sense.
One of Einstein's discoveries, Albert Einstein's discoveries, was that gravity changes the path of light. It can bend light. It's just not it's just not in our everyday experience.
Right.
When we're in a room,
and we still don't have any real evidence of that. So, gravitational lensing can be explained by other explanations, alternative explanations of atmospheres and diffraction and all of this other stuff that has to do with light interacting with particles, not light interacting with gravity. So you can say Einstein discovered it, but I'm going to argue that Einstein misdiscovered it. It's not the truth.
like this, or where you are, there's not nearly enough gravity to bend light enough to measure, especially with just human eyes.
Yeah, I know, but there should be enough, just by the sun, or we should be able to find something heavy enough to do all this lensing, and it just doesn't happen. And it doesn't happen because, what's the right way to say this? I mean, obviously you have to have you have to have a weak enough amount of light to bend it, I suppose, but that still doesn't make any sense. I'm still saying it's such a surface phenomenon that's the giveaway. It's there's too narrow a gap of distance where this lensing takes place for it to be a gravitational effect. The effect should have it should dissipate by the inverse square rule, and not as dramatically as it dissipates.
To measure it, we usually find objects way out in space, and we have known brightness, and we see where we think they're going to be and then where they really appear to be, and then we infer or figure out.
Right, you infer, and like I said, that we should have inferred, just because we do see that this light stuff happens, all kinds of diffraction happens with lenses and everything else, and that we should be able to understand or infer that none of those are gravitational effects explicitly. They're effects created by matter. Material things are creating the effect. Material things are gravity, but I'm just saying it's a different manifestation of distortion. The distortion has more to do with the orbit of the subatomic particles than the atmosphere of the universe.
That they're not where we thought they were going to be because gravity bent the beam of light. It's amazing. Anyway, so a black hole is a star so massive that not even light can escape from it. Now, when you
Right. So I would argue that yes, light can escape. It's just that there's nothing producing light in the direction of escape. It's how to explain. It's like things getting washed down a stream or something. You know, there's no swimming up the stream, and so once you're in gravity that intense, all the most of the directionality of all the matter is now being converted into pure energy moving in the direction of the fall. So in something that's accelerating that much, there's that powerful and accelerating force, there is essentially a conversion of the matter into energy, and the conversion will be completely in the direction. So it's like the school of fish analogy. It's like if I have 10 tuna fish that are swimming around in different directions, and I hit them with a swarm of 1,000,000 sardines, and the sardines all nudge them in the one direction, then I end up with 10 tuna fish swimming that way. You know.
You get something that big, the gravity as you get near it changes, and you know this. Like if you're real far away from a light bulb, it's dim, right? When you walk up really close to it, it gets brighter and brighter and brighter.
Well, the better analogy just might be the size thing, you know. It's like when the camera's over there, my arm's length, it's only this big. And if I move it here, wait a minute, it's not this big anymore, it's this big. Yeah, it's 4 times as big. So half the distance, 4 times the size change. There we go. But yeah, the light's doing exactly the same thing, and it's called the inverse square. And, you know, you might as well just say inverse square to a little kid, right? Go ahead and say it to her.
Well, the same is true of the gravity that a star produces or anything with mass produces. The closer you are to it, the more gravity it has. Satellites in space have less gravity to fight than you and I do here on the surface once they get out there in space, for example. So when you fall into a black hole, boom.
Yeah, but they're not really fighting gravity, so that's not really the right way to say it. But yes, technically we're the ones doing more. We're running at a higher velocity because we're bouncing in a heavier gravity, where they're releasing in a weaker gravity. So their releasing is like this, where our releasing is, you know, really high frequency releasing. So it's a frequency kind of thing.
First of all, you don't want to do that because the difference in gravity between your feet and your head, just that far, is so powerful it would stretch you into really, really thin.
Yeah, like a pencil, like spaghetti, he says. Yeah, but it's not even just a stretching thing, but I mean, obviously that would be part of the problem. But I'm not even, like I said, you don't really stretch. I mean, your matter will be converted into energy. And look, the same argument can be made with particle accelerators. The thing crashing into the, you know, whatever you're crashing into each other, by the time they crash into each other, they're not protons or neutrons or any of that stuff anymore. They're energy. You've converted it into energy. And you're just smashing, you know, radiation into radiation, and then saying, look at the little bits that are flying off.
Thin as a wire, thin as a piece of spaghetti, as the saying goes. And Bo, I don't want to shock you. That'd be really bad. But
yeah, well, you know, it wouldn't, yeah, necessarily because it's very quick. But regardless, the point is why don't you just say it overtly that this is all kind of crap. This whole idea that you can move matter the speed of light. It's absolute nonsense. There will not be any warp drive or any of this crap. It's never going to happen because the physics won't allow it to happen. Because matter can't go faster than the speed of light. Nothing can. The pieces inside the matter cannot travel faster than the speed of light. And therefore the matter has to be destroyed because the matter has movement inside of it. And that movement must be nullified for you to make it travel somewhere at some speed of light. Or the implication is the stuff has to travel faster than light. It can't.
in science fiction, We love that because we can fly around in spaceships and they have sort of science fiction magic powers and they can.
Yeah, well, why don't you just why don't you say it? Scientists really shouldn't be playing with science fiction. That's for real, that's just for wanking. And if you're going to do serious science, you ought to make a real clear distinction between what's real and what's fantasy. And yeah, that's fantasy. It's nonsense. It's fucking leprechauns. Traveling into a black hole is a leprechaun. It's a Tinkerbell. It's bullshit.
And we can survive stuff like that in stories. Now you mentioned wormholes. Wormholes are an idea.
I love that. He's just so copping out on this one. It's an idea. Yeah, I don't think it's much of an idea, but yeah, Suskind and other wacky guys think it is. But yeah, I think it's a wacky idea. So I just love how he's just tiptoeing around this one.
That people think may exist, and the idea.
Yeah, they're like God, they're like Jesus. Yeah, they pretty much. It's even worse because they don't even have a Bible of wormhole. They just made it up. They just said, let's turn the whole universe into like a bubble bath, and then let's pretend the bubbles hit each other, and let's call the thing where the two bubbles hit each other. Let's call that a wormhole. Let's just make a bunch of shit up.
The idea is that you would fall into something with a lot of gravity, like a black hole. And instead of just getting crushed and killed.
Yeah, well, actually, you wouldn't get crushed. You get exactly the opposite. After you go through the strong gravity, you fly into no gravity, which means everything just goes all loose. Yeah, loosey goosey. You know, so it's like the exact opposite. You don't get crushed, you get expanded into, yeah. It's what do you call that? Not an implosion. You explode. Yeah, that's what you do.
You would end up in another part of the universe at a different time.
Which is another.
And this is something that physicists say to each other at physics meetings, and
yeah, after they've had a lot to drink. No, they only actually. I wish you could say it was just drunken fantasy, but yeah, they're sober, which is even more frightening.
Oh yeah, you're a different part of the universe, different time. Yeah, that's great. Yeah, piece of cake, black hole, wormhole. Sure, that's sure. But understand, Bo.
Understand, Bo, that adults are full of shit, and you can't trust a motherfucking thing they say because they just talk absolute shit, and then they put on, these pretense like I'm a scientist. I know how to do some real fucked up math, and I can make funny symbols and multiply them by each other. And I can make a formula an inch long, and it has wacky symbol divided by kooky symbol divided by mushy symbol divided by icky. And there, I've solved the universe. That's the secret of life. Icky times divided by boo boo goo goo poo. There you go. Yeah, and adults are full of shit. They will just lie through their teeth, say absolute crap, and then, see, even like this guy, they'll soft soap stuff and try to say, well, it's sort of like becoming spaghetti. Instead, it's just saying every one of your cells will explode, and the cells themselves will turn into the most rudimentary material parts, and then the protons will actually fly out of all the atoms, and you will disintegrate.
Nobody's ever done this. These are theoretical things.
They're not even theoretical. They're fucking fantasies, and that's what you should call them. They're silly, bibbly, babbly fantasies that have nothing to do with evidence or facts or any of that shit that's supposed to be important to scientists.
Important theoretical things because they are consistent, or they're part of the bigger story that astronomers and astrophysicists and just scientists in general, they're part of the bigger story of the universe.
Well, they're not really, though, in any real way. They're only part of it in the fact that they made up a symbol that represents bullshit. And now they're bullshit times bullshit equals super bullshit. It's super string theory.
Where you and I came from, and what we're all doing here and why the Earth goes around the sun and why the other planets go.
Yeah, we know all that shit though. That's all the Newton stuff. It's rather rock solid, but this crap is not so solid.
Around the sun, and they're all in the same plane almost, except Pluto, which is going. And so it's all part of this big story. So these are great questions, Bo, but they really don't have clear, succinct answers right now. But
well, there we go. She didn't ask a bunch of questions. Just basically just said, what happens when you fall into a black hole? I think. Where do you go? You go dead. But you're probably going to be dead long before you even get to the black hole, because there's probably going to be a bunch of shit that's going to hit you in the head.
Perhaps you will be the scientist, the astrophysicist who figures this out for sure.
Yeah, and it'll do you no good. Yeah, you'll end up living in a fucking cobweb-infested, peel-and-paint shithole. And get no respect. That's the way the world works.
When you have these objects, or these theoretical places in space, that seem to have so much energy, you just got to wonder if we could harness that energy and do something fantastic.
Yeah, we can already do that with the nuclear thing, but that's the whole catch, right? If you tap the big energy, there's the big risk tied to it, because big energy means bigger mistake. One mistake and you let big out the door. So that's the sort of the tapping problem. But sure, it'd be really great if we could just nuclearize, really small things. Just nuclearize a little tiny grain of sand at a time. That's not as dangerous. So someday maybe we can do that. But like I said, I think we already have that theoretical knowledge. We just don't have the application knowledge.
I stick with it. Keep asking questions, Bo. This is great. Carry on.
Yeah, I don't know, but asking questions to idiots, I don't know what's the point. Don't ask an adult. Ask yourself questions. That's it, yeah. And then look for answers. But don't go asking somebody what the answer is, because they'll just tell you a big pile of crap. Either they'll tell you Jehovah, or they'll tell you multi-dimensional fucking wormholia. But they won't tell you the truth. Because people, what Bo is going to become, all expectations, it looks like she's going to become one, will just become assholes. So anyway, hey, that's just all this ad is up to. Gee, it looked like it was longer than that. I could have read it. That would have been that would have been stupid. So yeah, it's good I didn't do that. Anyway. Bo doesn't have a very good name. Why would somebody name a little girl Bo? It's just Bo Buchelman. Bo Buckelman. I mean, you could have called her Barbie or something. Fuck. Brenda. Bonnie. Yeah, Bonnie's a good name. I like Bonnie. Bonnie would have been better than Bo. But whatever. It'll give her whatever. Style points. So, it's important, I suppose. So what else is news? Yeah, so I don't know. There's an old Michio Kaku video. Not this one. This is 3 hours. But it's just kind of funny. There it is. There he is in 1991. And it's hilarious because he's saying exactly the same things he says now. It's 25 years later, and he's saying word for word. The exact same. We were looking for an equation, 1 inch long. The same rhetoric, the same exact stuff. And I was just amazed that he's saying the same shit 25 years later. So anyway, but he was, he's just so, we look at the whole stature. He's just so full of himself. Even then, he was just so, I'm Japanese physics man. He just has such a, it's just it's like a Pokemon character or something. I don't know what it is, but yeah, he's just so full of himself. Anyway, I invented it. He keeps saying he invented it. Yeah, he says it in this fucking interview, 1991. How come his name's not on the Wikipedia page for string theory? That it's not there anywhere. Where's his name? He's not there. Strange. Who cares? Whatever. I don't care. But anyway, do I want to say anything else more? Yeah. So I have to work out some mathematics here. But like I said, I'm thinking this is in a way that maybe this idea of the external gravity, just because you create this unique circumstance that inside the center. Let me just draw a quick little picture. By my theory, the gravity is coming from the external world. Uh-oh, this pen is running out of ink. Oh my. Yeah, that's officially not working. I was familiar with it. I don't like change. I hate change. Yeah. Gotta have a tooth fix. Got a new dentist coming. I don't like the idea of a new dentist. Anyway, so the center. So by my theory, the gravity is coming from the outside, and so in a normal gravitational body like the sun, let's say, there would still be gravity here in the center, but it'd be much weaker. So these nuclear bits are getting affected by less gravity because it can't get it's blocked all the way through here. So in a black hole, theoretically, there's no gravity that can reach the center. The gravity gets completely worn out until there's nothing. It's all blocked. So there's no pressure to hold the atom together, theoretically. I don't think it ever gets to that point, to tell you the truth. But I'm just saying that does have an implication. But you can sort of see what I'm saying, though, is if here would be the strongest block of the gravity would be through this widest diameter. So when I'm standing here, this is when the gravity is the strongest. If I was here, then the only blocking, this 3/4 part of the Earth is doing the blocking. So I'm actually in less gravity, and less and less. And then when I get to the center, again, it's less gravity, but it's now at least it's balanced. So I don't have there's no acceleration at the center, but there's a lack of gravity pressure. But there's plenty of atomic pressure in here. So the atoms are still getting pushed into each other, and since they're still moving towards the center. But the forces holding the atoms together are weakening, and so the atoms are probably getting fatter, which is kind of funny. But I think that's what just creates all this. I think at the center of all the planets are thermally active, and for good reason, because everything's having a hard time staying together. Anyway, I think that's enough for this video. So much to go over and get through and move on to and whatnot, and I have to order all this. But what can I do? I can go a piece at a time, right? So till the next time, such.